Just what make a man feel this way, like river without its water, like night without a day. And the sun got cold after the rain fell, not from the sky, but from my eye.
Some of you may already be freaking out as you're watching me go through the preview as I kind of get myself ready to go. You're seeing all of these formulas and all these numbers. It looks intimidating. It's really not that hard what we're going to be doing. But we are going to be talking about some calculations in this video. Specifically, we're going to look at different methods for calculating the combined sound level from multiple sound sources. In many workplaces, there's not just one machine that is making all the noise. There may be 4 or 5 machines that are combining to create a sound level that then affects the workers. And that's what we're going to be looking at in this video, and that's the only topic in this video, are the different methods for calculating combined sound levels from multiple sound sources. As I've already said, this is a common workplace characteristic, multiple sources of noise. We need to be able to calculate sound levels from those combined sources. This is, there are a lot of the quantitative methods that we cover in the safety profession and in the safety sciences that aren't that applicable in the workplace necessarily. These methods are applicable. There are uses for these methods. Again, multiple sound sources with each source generating the same sound level. This is one of those circumstances that you might encounter as a safety professional. Again, multiple sound sources with each source producing the same decibel level. Find my pen here. If we encounter that circumstance, this would be the formula that we would use. Let's talk a little bit about the formula. SPL subscript total, combined sound level of all the machines. Sound pressure level total. SPL IND, subscript IND. This is the sound pressure created by each individual sound source. I mentioned machine here. It could be other sound sources besides a machine. The other variable, number of identical machines, the number of machines or sources that are producing the same sound level. So we've got SPL total, SPL IND, we've got N, and then we've got 10, which is a constant, and then the logarithm function like we saw in some previous videos. Pardon me, frog in my throat. So let's go ahead and look at a sample problem. What is the combined sound pressure level from 5 identical machines if each machine is producing 85 decibels? Well, first of all, it's not 85 plus 85 plus 85 because the decibel scale is a logarithmic scale. Adding up the contribution or the sound level from each of those machines will not give us the correct sound level. to find the sound level for these 5 machines, again, here's our formula. Plug in 85 for the amount of sound being generated by each of the machines. Again, each machine is producing 85 decibels, so plug in 85 for SPL IND. There are 5 machines, so for N, we plug in 5. Take the logarithm of 5, that ends up being 0.7. The logarithm of 5 is 0.7. Multiply 0.7 by 10, 7. 85 plus 7, that gives us the combined sound level for these 5 machines. Pretty easy stuff, pretty easy stuff. Now, a lot of times we're not going to have machines that are identical and producing the same sound levels, but if we do, this would be the formula, the method that we would use to find the combined sound level created by the machines. What maybe is more common would be having multiple sound sources and each source generating a different sound level. There are a couple of methods that we can use. The first method that I want to show you is a shortcut method or a simplified method. It can be referred to as the source pairing method. But we can use this method to answer this type of question. What is the sound pressure level produced by 4 machines? The SPL, the sound pressure level of the machines, are 88, 92, 97, and 93. Again, we don't add them up. We have to use this method or another method that I'm going to show you to find the combined sound level. To use the source pairing method, there's not a lot of math involved, but there are multiple steps. The first thing we need to do are pair the different sources. Again, this is our problem. What is the sound pressure level produced by 4 machines? SPL of the machines, 88, 92, 97, 93. So we're going to have one pair made up of 92 and 88. 92 and 88. Machines producing 88, machine producing 92. That's one pair. Then our second pair, 97 and 93. Machines producing 97 decibels and the machine producing 93 decibels. After we have them paired up, we then need to find the decibel level increase for each pair. And what we're going to do is create a new pair. Out of these 2 pairs, we're going to create a new pair. But we're going to make adjustments to the decibel levels for each of these pairs. And here are the rules for making these adjustments. If the machines are the same or within 1 decibel, we're going to add 3 decibels to the higher decibel level. Just looking at a pair here. We're not looking at individual machines. If the machines are the same or within 1 decibel of each other, we're going to add 3 decibels to the higher decibel level. If the machines are different by 2 or 3 decibels, we're going to add 2 decibels to the higher decibel level. Machines are 4 to 9 decibels apart, add 1 decibel. If the machines are different by 10 decibels or more, we're not going to make any additions, but we're going to use the highest of the 2 decibel levels to bring forward. So let's compare 92 and 88. There are 4 decibels separating these 2 machines. So the machines are 4 to 9 decibels apart. We're going to add 1 decibel to the higher decibel level. So we're going to add 1 to the machine that's generating 92 decibels, and that pair, the combined decibel level for this pair, is going to be 93. Now we do the same thing for the other pair. 97, 93, also 4. So we also are going to add 1 decibel to the machine having the higher decibel level. So we add 1 to 97 and 98. That's step 2. Step 3, we continue this process. We compare 93 and 98. We look at 98 decibels and 93. there's a 5 decibel difference between these two machines. So that's also in the 4 to 9 category as far as being decibels apart. So we're going to add 1 to the 98 decibels, and we end up with a value of 99 for the combined sound level for these 4 machines. Let's look at another example, and I do want to say I'm going to show you I'm going to show you another method that we could have used, a method that's more quantitative, that involves more calculations. That on the surface, that other method looks a lot more reliable, a lot more valid, but we end up with the same answers using both methods. We use the source pairing method or the quantitative method, we end up with the same values for these 4 machines. But let's go ahead and look at another example for the source pairing method. What is the sound pressure level produced by 4 machines? The SPL of the machines are 71, 91, 85, and 87. Okay, we have one pair of machines, 71 and 91. The other pair, 85 and 87. I'm going to go a little faster. Good thing about videos, if you need to, you can slow it down. You can rewind if I go too fast. So let's look at this first pair, 71 and 91. That is 10 or more decibels. So what we're going to do, we're going to use the higher. The rule for using this method says that if the machines are different by 10 decibels or more, you don't do any addition, you just use the highest of the 2 decibel levels, which is 91. Now for the other pair, we have 85 and 87. There's a difference of 2 between these 2 machines. The difference of 2, if there's a difference of 2 or 3, we're going to add 2 decibels to the higher decibel level. So 87 plus 2, 89. Now we look at 91 and 89. There's a difference of 2 between 91 and 89 also. A difference of 2, add 2. So we add 2 to 91. That gives us a combined sound pressure level for these 4 machines of 93 decibels. Both of these examples so far, we've had an even number of sound sources. Let me do one more example, and I'm going to show you how you could use this method if you had an odd number of sound sources. In this example, we have 5 sources. The SPL of the machines are 88, 91, 92, 97, and 93. Okay, we have one pair, 88, 89, 88, 91. Another pair, 92 and 97. But then we have an additional machine. What do we do with it? We can't pair it up with another machine. What we do, we just leave it out there as an individual machine until we get to the very end. We go ahead and look at the pairs that are formed at this stage, just like we did on the previous problems. When we get to the very end, that end value will then will pair it with the individual machine that's left over. Step 2. Go ahead and bring all this up here. Compare 88 and 91, a difference of 3. So we're going to add 2 decibels to 91. 97, 92, a difference of 5. So we're going to add 1 decibel to 97. So we end up with 98, 93. Looking at that pair, there's a difference of 5. If there's a difference of 5, we add 1 decibel to the higher, so we add 1 to 98, gives us 99. Once we've reached this stage, then we'll take this value and pair it with this value. 99, 93, a difference of 6. A difference of 6 tells us to add 1 decibel to the higher value. So we add 1 to 99. The combined sound level for these 5 machines is 100 decibels. And what we end up here, we have the first step, we have 2 pairs, then we have a 3rd pair, then we have a 4th pair. And then when we get to the very end, we have our combined sound level. And if we use the quantitative method with the formula, we end up with the same value, about 100 decibels, or 100 decibels being the combined sound pressure level for these 5 machines. Now, let's go ahead and take a look at the quantitative method using the formula. Again, don't be intimidated by the formula. It is kind of intimidating looking, but it does have some terms that we've seen before. We've seen the log term, the logarithm function. We've seen the constant of 10 before. And everything in this formula is a constant except for the one value, the sound pressure level of the different machines. So let's go ahead and do a problem. And the problem I'm doing is the one that I just did with the 5 machines. We did the source pairing method with these data. Now I'm going to do the source pairing method, or I'm going to do the quantitative method with the same values. What is the combined sound level for 5 machines? Each machine produces sound levels of 88, 91, 92, 97, and 93 decibels. Let me back up a little bit before I get into this and talk a little bit about this term. This is actually a multiple part term here. We're using the summation operator. That summation operator is telling us that we are going to have multiple terms that need to be added together. And let me go ahead and, having said that, come back down here to this stage in the formula. This is the formula fully written out. We have 5 different machines, so there's going to be 1, 2, 3, 4, 5 terms in this part of the formula. That's all this part of the formula here. That's in brackets. Now I've circled it in red. This part of the formula is this part of the formula with all the values plugged in and the formula completely written out. This is a shorthand notation mathematically for telling us what to do. This is what we actually do when we follow that shorthand notation. We have 5 different terms. We do the calculations for each of those terms, and then we add them up. For each of these terms, let's just look at the first one here. We have 10 to the power of L sub pi divided by 10. L sub pi are these sound levels. L sub pi are these sound levels. So for this first term, we have 10 to the power of 92 divided by 10. That takes care of that machine. The next term, we have 10 to the power of 88 divided by 10. Again, 88 divided by 10. Third term, 97 divided by 10. 10 to the power of 97 divided by 10. Fourth term, 10 to the power of 93 divided by 10. And the last term, we have 10 to the power of 91 divided by 10. Okay, now we have everything plugged in that needs to be plugged in. Now we have some math to do. And the math that we're going to do, we're going to end up with a very huge number. We're going to take 10 to the power of 9.2 plus 10 to the power of 8.8. You can do all this in your scientific calculator. If you have any questions about using your scientific calculator, let me know. But 10 to the power of 9.2 plus 10 to the power of 8.8 plus 10 to the power of 9.7 plus 10 to the power of 9.3 plus 10 to the power of 9.1. When you get all of that into your calculator and you press enter, you end up with 10,481,910,600. Again, big number. You're not going to be doing this by hand. You shouldn't be doing this by hand. Use your scientific calculator. Now we need to take the logarithm of the value in the brackets, that 10 billion value that we came up with. Take the logarithm of that. When we take the logarithm of that value, we end up with 10.02. Last step, multiply 10.02 by 10. We find that the combined sound level for these 5 machines is 100.2 decibels. When we used the source pairing method for these same numbers, we came up with 100 decibels. So we were very close with that approach. Now, if we need to be precise, use this method. Use the quantitative method. If we need to be precise down to a tenth of a decibel point, or even more precise, use this method. But if we just need an estimate that's going to get us very close, and sometimes that's all we'll need is an estimate that gets us very close, then you can use the source pairing method. that will get you very close. Alright, that's it for this tutorial, and in this video we've looked at different methods for calculating the combined sound level when we have multiple sound sources. Let me know if you have any questions.